Hey, Geo, check out what I'm picking up from one of our remote field cameras.
Ah, a small rock slide, which happens to be a great example of weathering, erosion, and deposition at work.
Weathering, erosion, and deposition? Gee, those guys sound pretty important.
Weathering, erosion, and deposition are very important, Iggy, but they're not people. They are forces that naturally change the Earth's rocks and soil. Let's merge our data banks so I can fill you in on these processes which have shaped the Earth's surface for millions of years. Iggy, weathering, erosion, and deposition are natural processes that are wearing away at the Earth's rocks and soil all the time. Weathering is the way rocks get broken into smaller and smaller pieces, sort of like what this girl is doing here with hard dirt. Except that weathering usually happens much slower, taking many, many years to occur. When the pieces of rock get carried away to other places, we call it erosion.
I see, sort of like a kid moving broken up pieces of dirt.
And when these pieces of rock and soil are placed or deposited in a new location, we call it deposition.
Oh, like where the kid drops the broken pieces of dirt in another spot.
Very good, Iggy. Weathering is happening all the time, everywhere on the Earth's surface. But it is usually a very slow process. If a person spent his whole life living in one house with a big rock in the backyard, he would probably never see any noticeable changes in the rock's appearance.
Then how do we know weathering happens at all?
Sometimes you can see it in action. Remember the rock slide?
Oh, yeah!
And we can see what weathering has done in the past. Look at these rocks. They were shaped by weathering.
So what makes weathering happen? I thought it might have something to do with the weather. But when I think of weather, I think of rain, snow, wind, stuff like that.
Very good. Those forces and others cause weathering in two ways: physical weathering and chemical weathering. Physical weathering is how rocks get cracked, broken up, and worn down through physical action. Iggy, have you ever heard of something called abrasion?
Isn't abrasion what happens when kids fall down and scrape their knees on the sidewalk?
Yes, it is. In fact, the abrasion that happens to those knees is a lot like the abrasion that happens to rocks because of solid particles carried by water and wind. Have you ever seen a painter sandblasting away old paint? Small sand particles are used to scrape the old paint away. Although it acts much slower, wind-blown sand can do the same thing to rocks. Look at these unusual rocks. They were shaped by abrasion, thousands of years of scraping from wind-blown sand.
Wow, natural wind art.
Yes, and moving water is even more powerful, as it can carry larger rocks as well as sand and mud. These rocks pound and grind away at each other, and anything they move over. This happens in rivers and at seashores, where the waves pound the land. That's why you'll find so many rounded stones in these locations. The edges of these stones have been worn smooth by all the grinding.
Looks rough.
It is, and it goes on night and day. In fact, the change from night to day is another cause of weathering.
Why is that?
Actually, Iggy, I'm going to need a little help on that. My files aren't complete.
Then let's call up the Kids Into Doing Science Club for more information.
Kids Into Doing Science, I'm Alan. I'll be your guide today.
Hi, it's Iggy and Geo again.
We need more information on how the change from night to day can break up rocks.
Sure, just let me get the file. Though you can hardly see the change, heat makes rocks swell or get larger, while cold weather makes them shrink. After a long, cold, dark night, the warm sunlight can cause rocks to crack. If water gets into the cracks, it can cause more problems when the cold night comes again. You see, when water gets very cold and turns into ice, it actually swells or expands.
Really?
Yes, you can test it. Take a 1-liter plastic water bottle and leave it in the freezer overnight. In the morning, check it. The water bottle will be swollen because the ice inside it is bigger than the water was.
Okay, but that's a thin plastic water bottle. What can ice do to rocks?
Expanding ice is very strong. It can easily widen a crack in a rock. All this swelling and cracking is one reason you often see piles of broken rock at the bottom of rock cliffs. The rocks crack off and fall to the ground below.
Wow, that's cool. Or cold.
Glad I could help. Talk to you soon.
Geo, the swelling of ice can really cause problems for rocks, can't it?
That's right. So sometimes people try to protect rocks from being damaged by ice.
What kind of rocks could be so important?
Well, let's take a look.
This is Mount Rushmore National Memorial in South Dakota. Mount Rushmore is the world's largest sculpture and features giant carvings of the faces of 4 United States presidents. Representing many years of hard work by hundreds of people, Mount Rushmore is an extremely important national treasure. But the giant carvings are in danger of changing due to weathering. You see, even though Mount Rushmore is made of an extremely hard rock called granite, it has natural cracks because of the way it formed. Granite forms from volcanic activity, when hot melted magma pools up and cools deep underground. After thousands or millions of years, as the layers of rock above the granite are worn away, the granite dome or mountain is exposed. As the rock is now exposed to the forces of weathering, the granite swells a bit and cracks. Workmen did the best they could to fill and patch these natural cracks as they carved Mount Rushmore. But water still gets into the cracks and freezes. So while granite is an incredibly strong type of rock, ice can create the kind of force needed to break the rock. Let's see that in action. Here is a granite cylinder that has been drilled so it can be filled with water. Extremely cold liquid nitrogen is being sprayed over the cylinder to freeze the water in it. And look what happens. As the ice forms, it swells and shatters the granite. This same thing is happening on a much larger scale on Mount Rushmore. When water gets into the natural cracks in the rock, it can freeze and make the cracks larger and larger. Here you can see a long crack on George Washington's head. So what is being done to protect Mount Rushmore? The cracks are being sealed with a special material to keep the water out. The material has to remain flexible so that it can shrink and swell with the rocks as they cool off and warm up. If the water is kept out of the cracks, ice can't form in them. And Mount Rushmore will be preserved for many generations of visitors.
Iggy, can you guess what else can make the cracks in a rock bigger?
More ice?
Actually, I'm thinking about plants and animals. Have you ever seen tree roots lifting or breaking up a sidewalk?
Oh, yeah.
Once a small root gets into a crack in a sidewalk or a rock, it can push outward very strongly as it grows. This can easily widen the crack.
But animals don't have roots. How do they break up rocks?
Animals, like prairie dogs and mice, dig their homes into and between soil and rocks. These holes allow the temperature and moisture to affect the rocks more. The holes can also cause rocks to break loose and roll downhill. So, Iggy, do you think you have all the data you need on physical weathering?
Let me check my memory banks. Physical weathering breaks rocks into smaller and smaller pieces because of abrasion, temperature changes, ice, plants, and animals.
You've got it!
So what's chemical weathering?
Chemical weathering is the changing of rocks into new substances.
Whoa! What powerful forces can cause rocks to change like that?
Well, take water for instance. You might be surprised to learn that water is responsible for a lot of chemical weathering.
I thought water worked on rocks through physical weathering.
Well, it does both. Have you ever seen sugar melt away and disappear in water?
Sure.
The water dissolved the sugar. The sugar is still in the water. You can even taste it.
Water can dissolve sugar, but it surely can't dissolve rocks, right?
Actually, it's what's in the water. Maybe this will make it clearer. Water can dissolve more things on Earth than any other liquid. And in nature, water often contains small amounts of other chemicals called acids. Acids are chemicals that break down or change other things. Some strong acids can even dissolve metal. So, many of the minerals that make up rocks will very slowly dissolve in water with a little acid in it. However, some rocks dissolve much faster than others. This can be shown through a simple test. Place small granite pebbles in a jar and a piece of chalk, which is limestone, in another. Add a little bit of water to each jar. If you were to let the chalk soak in the plain water for many days, the water would actually change the chalk a little bit. But let's speed things up. Add some carbonated soda, which contains a weak acid, to the water in both jars. You will see bubbles begin to form as the acid reacts with the chalk. Let your jars sit for a few days, and you will see that the acid in the soda dissolve most of the chalk away. The granite, however, will not show any visible effects from this acid. Though weak acids in the water will dissolve the granite, the process takes many years. Carbonation is what makes the bubbles in soda water. And it also makes the weak acid that dissolves limestone. That's why you get those crazy